Hello everyone, you are watching Bytes of AI, and today I'm going to show you how to implement RAG using open source model. And today we are going to use Microsoft's latest model, large language model 5.4, and along with that I'll also use ChromaDB, the vector database, and LangChain. Let's start with RAG implementation using 5.4. And before that, I would highly recommend to go through my past videos, which explains the RAG architecture and also the RAG implementation using OpenAI. So RAG implementation using OpenAI is in my left-hand side panel, and I haven't changed much in that. Uh, this is as it is. It has been kept here, and this is the right-hand side panel shows the implementation of RAG using 5.4. So before I go into details, because I have just kept the entire coding mostly same, apart from you can see that last 4 lines of this import statement. So I have used some new imports now, like transformers, then bits and bytes config, etc. So main reason behind that is in OpenAI, we have to just call an API to load, to infer from GPT-4o Mini model. So it's just an API call, which I have used in this particular code. But in this particular code for 5.4 or any open source model, you just can't use any API. Rather than you have to load the model in your own memory. And then you have to use that particular model for inference, for the inference. So first we need to know, like, how do we calculate the memory requirement for that particular model to load into memory. Let's go to one of the page. So memory requirement specifically depends upon that architecture of that model, and this is a model summary for 5.4 from the Hugging Face website, and you can see in the architecture section it's required 14 billion parameters. So after training the model, it has total 14 billion parameters, which actually store its weights of the model. This is very important information to calculate the memory. And there is a nice memory calculation logic as well. This is I'll just give this link of these pages in my description. So here we can show that how much memory is required to actually load that LLM model. This P is basically the amount of total parameters which we have shown for this 5.4 model. It is 14 billion. 4 bytes is the number of bytes originally used to store those individual parameter. Then 32 divided by Q. Q is one of the figure which actually says that amount of bits that should be used to load the model. So I'll come into that. So Q means here we have a way to actually reduce the precision of the model. So as I mentioned that originally the model used 32 bits precision, that is 4 bytes to store its parameter, but we can actually load each parameter instead of 32 bits. We can use just like 4 bits or 8 bits or 16 bits. So what does that mean? Like instead of 32 bits, we'll use lesser bits to store the weights, and that will reduce precision of the model, precision of the parameters as well. So we may observe some losses for that, but that is not very significant as well. So this is the way we calculate the memory, and so we have now information like 14 billion parameters which we can replace here, and Q is in. So if we want to calculate what is originally required, so Q would be 32 in this case. Like in original it is 32 bits to store each parameter, so Q would be 32. So let's see how much is the memory required in 5.4 to load the 5.4. So I have just created a spreadsheet to calculate that. You can see this is the model name, then amount of parameters in billion. There's 14 billion parameters, amount of bits used for loading model. So this is 32 bits originally used for loading the model, and then original number of bytes for each parameter, that is again 4 bytes again, that is according to the formula which we showed a few minutes back. And then this is the load factor, means apart from the calculation, that is 20% of overload or loading additional things in GPU memory. So that is multiplied by 1.2, as we just checked in this formula. This is multiplied by 1.2. Now if we use all those things, so it comes like 67.2 GB of memory required. So I'm using the GPU that do not have that much capacity, 67.2 GB of GPU memory. So it has like 24 GB of memory. So I have to contend within that. So what I have done, I have used a formula, used a configuration that is to load this 32 bits model, means 32-bit parameters model into 4-bit parameters model. So originally each of the weights used to get stored in 32 bits, but now it will get stored in 4 bits instead of 32 bits. So that's, we are reducing the precision, but also it will require less memory and less computation power. So let's see that how is the new memory requirement. So here you see that amount of parameters is still remaining same, but I have reduced it to this to 4 instead of 32. And other figure remains same, and this figure comes down to 8.4 GB memory instead of 67.2 GB memory. So that is well within my GPU memory requirement. So this means I would be able to load this particular model with quantized version of this. So this is implemented in the code using this configuration. You can see from line number 50 to 55 that bits and bytes config. So load in 4-bit equal to true. Then quantization type is NF4. NF4 is a specially customized 4-bit quantization type to reduce the loss for change in precision. And then this is double quantization, so it will just double quantize this to true. And the data type to store that 4-bit is float 16 b float 16. So this is the configuration which we'll use to load the model. And these are the tokenizer, and then a model is getting initiated using the model ID and quantization config, which is NF4 config, which we have just defined here. And this is the transformers pipeline to initiate the pipeline, and then finally we are using Hugging Face pipeline to define the LLM. So see the difference. Earlier we just used in OpenAI, we have just used in the left hand side panel, if you see that it's like just one call, chat OpenAI, and then mention the model name, it is GPT-4o Mini, and temperature 0.0. And here in this case it is like we have to kind of optimize to load the model into memory, and for that we are defining bits and bytes config, and then we are using Hugging Face pipeline to finally initiate the large language model. So this is the major change in loading the model, loading the open source model, and it will remain same for most of the model, most of the open source model, this configuration. Only thing, like, you have to probably calculate the memory requirement first and check like whether your GPU supports that or not. And if it supports, then you can, this particular code will work. And I haven't changed much from the left hand side code, with OpenAI implementation, apart from this additional function here, which actually, so the response returned by LLM is not uh, exactly same as the written by OpenAI. So I had to little bit tweak to get the exact response, the summary informations of the response of the questions. So I have written this function for that. And also one more test I have, more change I have done. So here you can see that I have used RAG class loader v2, and if I go to RAG class loader v2, I have defined get results here. So get results, why I have defined, because in this open source case, I could not use get retriever, which actually used to return the retriever to search from vector store. So I could not use that. So I had to use a function get results, which will again define the vector store, but along with that, uh, it will just, I'll use one of the function like vector store similarity search, and with the query is the which is given by user, and k equal to 3 means top 3 response returned by vector store. So that is the change I have done, and that is one of the change I have done apart from existing OpenAI implementation. And one more change I have done, I have just, yes, so I have just joined uh, all those three uh, response returned by vector store uh, in this way. So each of the document returned by the query result, I have just appended that, and along with that, I have also appended the source information. So that is the only change I have done. So it's the first how to load the model. That is one change. Second is that instead of vector store retriever, I am using a straight string return, and then I'm just joining those string into a text, and finally I'm sending that text into a system prompt. So after that, yes, there is one more change actually. So here in the left hand side, you will see that in open source implementation, I have used system prompt. So that is also same there, same in right hand side implementation. Then yeah, I have used the chat prompt template from message, and then query answer chain. Then I used the create retrieval chain, and then finally use that to invoke the LLM. But here I haven't done those things straight away. So I'm not introducing any chat prompt template or any retrieval chain here. It is straight away I'm defining a message list, and in that list I'm just appending my system prompt, which is a defined top, and then I'm appending query, which is kind of given here, what is position and encoding. Questions I have kept in both the cases same for a demonstration like how it behaves. And yes, after that I'm straight away just using LLM to invoke this message, and I'm using my predefined function, this extract assistant response, to get the response. That's all about the open source implementation or 5.4 implementation uh, for the RAG. So now let's quickly run this thing and check how it goes. So again, as you can see, I have used Visual Studio Code as my IDE. So let's first initiate my virtual environment. So let's run the OpenAI implementation first and check how is the output, and then we'll run the similar thing on 5.4 and we'll test the result. Okay. So you can see that 49 chunks to ChromaDB added, and then the answer is like positional encoding is a technique used in models to provide information about the position of elements in a sequence. It adds a unique representation to each position in the input sequence, allowing the model to understand the order of the elements. In this context, the sine and cosine functions of different frequencies are used to create positional encodings that can be summed with embeddings, enabling the model to learn to attend to relative positions effectively. So this is the response from OpenAI. Now let's see how 5.4 returns. Before that, let me clean up the vector database. So I have cleared my vector store, and I'll run this again with 5.4 model. So you can see that loading checkpoint search. So that means it is loading the open source model into my GPU memory. And you can see here like 4 out of 6, 5 out of 6, then 6 out of 6 it will tell. So that memory is kind of fragmented into 6 parts. So it is just joining it, just uploading into memory and then use that together as a whole. And after that, you can see that 49 chunks to ChromaDB. It is same as earlier, the same file we are uploading, and this is the input output return. You can see it is kind of uh, let's say what it has written. Positional encoding is used to give the model information about the position of the tokens in the sequence. In this work, sine and cosine functions of different frequencies are used for positional encoding. Each dimension of the positional encoding corresponds to a sinusoid with wavelength and a geometric progression from 2 pi to 1000 c dot 2 pi. This allows the model to easily learn to attend by relative positions and offset, etc. etc. So if I analyze these two things together, the response together, it seems to me like 5.4 is giving a better response compared to the OpenAI. It has also tried to include the formula as well, like wavelengths forming a geometric progression from 2 pi to 1000 c dot 2 pi. I'll ask a maths question actually to both OpenAI and 5.4 model, and I'll check that which one gives a better response. Okay, so let me clear this and okay, let me just comment out. This time I will not require vector store. I'm just keeping this as it is to do minimum change here. And let me see if anything else I have to do. Okay, what I'll do, I'll also comment out this system prompt and I'll just use this one instead. What I'm telling here, you are an AI assistant that follows its instruction extremely well. That's all, nothing complex. And what I also do this time, so I kept this temperature 0.0 because I wanted it to use the information only from the context, but this time I'm not providing any context here. So I'll kind of telling this OpenAI model to be creative enough to give me the answer. So let me check whether this is running or not. Okay, let me first go before that, let me go through the question. This is interesting questions. Interesting maths question. A caterpillar crawls up a pole 75 inches high, starting from the ground. Each day it crawls up 5 inches and each night it slides down 4 inches. When will it first reach the top of the pole? So the question is that a caterpillar crawls up a pole 75 inches high from starting from the ground. Each day it crawls up 5 inches high and then in the night it slides down 4 inches. And if this goes on, then on which day actually it will reach to the top of the pole? So that is the question. So let's run this with OpenAI model and check the output. Okay, so let's see how it goes. So each day the caterpillar crawls up 5 inches but then slides down 4 inches. This means the effective progress of the caterpillar makes in one full day is 5 minus 4 equal to 1 inch. That is okay. However, on the last day, if the caterpillar reaches or exceeds the top of the pole during the day, it will not slide down that night. Good. Daily progress calculation is at the end of the day effectively climbs 1 inch. After n full days, the caterpillar will have climbed n inches. Okay, that's correct. Now let's consider the situation just before the last climb. Okay, at the end of the day, n, the caterpillar has reached n inches. On the next day, n plus 1, it will crawl up 5 inches. That is true. We need to find the smallest n such that n plus 5 greater than equal to 75. That's nice, actually. It is bringing into some logical inequalities equation. This simplifies to n greater than equal to 75 minus 5, n greater than equal to 70. So after 70 days, the caterpillar will have climbed to 70 inches. That is okay. On the 71st day, it starts at 70 inches in the morning. It crawls up 5 inches, reaching 75 inches. At this point, it has reached the top of the pole and will not slide down that night. Thus, the caterpillar first reaches the top of the pole on the 71st day. Wonderful. That's a great answer, I believe. Let me see how 5.4 returns. For that, I'll just clean up something and let me clear the screen. And now I'll run the model with 5.4. I just will check if I can include anything here. Question is same and system prompt is also same. I have given here. Okay, let's run this thing. Let's get the response back from 5.4 model now. So it's loading the large language model in GPU memory. It will take some time and then it will give the answer. Okay, it is some warning message because I have just set temperature to 0.7, but I think it is telling that we have to also set to sample true or unset temperature. Okay, anyway, let's ignore this and check what is the answer here. To solve this problem, we need to determine how many days it will take for the caterpillar to reach the top of the 75-inch pole given its daily progress and nightly regression. Each day, the caterpillar climbs 5 inches, but each night it slides back 4 inches. Good. Therefore, the net progress the caterpillar makes each day is 5 minus 4 equal to 1 inch per day. However, this net progress calculation only applies until caterpillar is close enough to reach the top without sliding back. Oh, that's nice. Let's calculate how many days it takes to reach a point where it can reach the top in one final climb without sliding back. Wonderful. Calculate the effective progress needed before the final climb. Okay. If the caterpillar reaches 70 inches by the end of a day, it can climb remaining 5 inches the next day and reach the top without sliding back. Excellent. I think it has almost reached the conclusion. Determine how many days it takes to reach 70 inches. Great. Since the caterpillar makes a net progression of 1 inch per day, it will take 69 days to reach 69 inches. That is fine. Final climb on the 70th day, the caterpillar climbs 5 inches from 69 inches, reaching the top of the pole at 74 inches plus 5 inch equal to 70. Oh, something is wrong here, right? Means on the 70th day, so 69th day it is at 69 inches, so 70th day it will be at 69 plus 5, 74 inches. It is not the top, so it should again slide down 4 inches. It should be then at 70 inches at the end of the 70th day, but somehow it has done some miscalculation here. It is just telling that 74 inches plus 5 inches equal to 79 inches, which is beyond 75. Oh my god, that the caterpillar will first reach the top of the pole on the 70th day. Oh, it just missed by 1 day, so it has almost mentioned everything correct till this. Then after that it has suddenly taken 69 days as the last day before reaching the top of the day. Though it has mentioned that determine how many days it takes to reach 70 inches, that means it identified that 70 inches is the target, and that should ideally be reached by 70th day. Then on 71st day it should reach the 75-inch pole. So although it has described very nicely by reasoning, it has given very good reasoning, but it failed to answer correct. But whereas OpenAI has really done a great thing. I don't have that answer now, but it has very logically deduced and then finally gave the correct answer. I expected 5-4 to give the correct answer as well, but for some reason it missed the mark. I don't know. But anyway, my overall conclusion is that 5.4 being the latest model, it has really performed good. So from the RAG point of view, it has given pretty good answer. Like it was more informational compared to OpenAI, because 5.4 included some description about the mathematical equation as well, which was missing from OpenAI response. And this independent maths question perspective, OpenAI gave a really good answer. It tried to explain very well manner and it got the correct answer. 71st day would be the answer. And in case of 5.4, it also means reasoning was very, very interesting. Means as a student, if you get that kind of reasoning, you understand really very well. But at the end, somehow it did some miscalculation or something happened. It could not answer the correct one. So it just ended with 70th day, which is wrong answer. But anyway, 5.4 uh, with the 14 billion parameters, I think it has answered quite smartly. If you are using very hugely, then probably at some point of time you will get the benefit from open source LLM, because you don't have to spend a lot for using the LLM, because this LLM, open source LLM, is owned by you, and you have tweaked it your own way, and you are not pricing apart from using your own infrastructure. So you have to just see the trade-off, whether you should use OpenAI API or any open source LLM for that reason. Please don't forget to like and subscribe. It motivates me to bring out more contents, and also do leave your comments regarding any new topic which you want to hear from me. That's all. Thank you. Thank you for watching.